So hi, today I'm gonna tell you about chemical nomenclature and it's by me, Ale Alvarez. So first I'm gonna start by telling you what it is. So this is rules to name chemical compounds and can be used in four ways: in binary compounds, ternary compounds, acid compounds, and covalent. As you can see, like each type has within two types, and today I'm gonna show you how to kind of use them all and the way you use them, the way you set them up, and an example. So ionic compounds is combining ions and cations and anions to form chemical neutral compounds. So the first step I'm gonna be showing you today is binary ionic compound, and this consists of two types, and they're usually metal that are positive and non-metal that are negative. So the first binary compound is type 1 and the metal, and this is like a metal with a specific charge, which are representative elements that are the ones that we usually use in the periodic table. They're the most known, plus a non-metal that is negative. And the formula unit is the symbol of metal, so the positive ion is first, then the non-metal, so the negative goes second. Sorry about the spelling. And then the subscript usually shows lowest ratio of atoms needed to have a neutral compound. And the rule is metal is first, the name of the metal doesn't change. So like the ending of the metal doesn't change. But when it's a non-metal, when it's the second, because first is the metal, then you name the non-metal, and the non-metal does have a changing in the end, and it changed to IDE. An example is magnesium, and magnesium has a charge of positive 2, and chlorine has a charge of negative 1. So when we want to join them and they have to be balanced. So we will need for it to be like positive 2 and negative 2, so it balances. We'll need 2 of chlorine, making it MgCl2, making 2 of chlorine to be balanced, which this is named magnesium chloride. And because chloride is a non-metal, you have to change the ending to IDE. So in this case, we changed it. Moving on to binary type 2. So binary type 2 is a metal with several charges, which are transitional metals, that are usually in the center of the periodic table, that we use them but not as common as the represented metals. And they are those type of metals plus non-metals. The formula unit is the same as binary type 1, and the rule is metal goes first, followed by the charge of the metal in Roman numeral between parentheses. Because this metal some have specific charges, so it has let's say iron has charge of 2 and charge of 3. We put the parentheses of the charge we are gonna use in Roman numerals, and the non-metal goes second, and the ending change to IDE. So if first goes the metal, that doesn't change, and then the non-metal does change to IDE. Here's an example of E. Eve parentheses 2, iron has a charge of 2. And you'll be answering asking why parentheses 2. It's because iron has two type of charges. It has iron of charge of 3, which in this case we're not going to use. We're going to use the one with charge of 2. And if we were going to use the one of charge of 3, we would have put in a parentheses of 3 in Roman numerals, but we're not going to use that type. We're going to use the one with 2. And oxygen, which has a charge of negative 2, and iron of charge of 2 and oxygen balance out equally because it's 2 positive, 2 negative, which balance out, making the equation FeO. And this would be named iron, parentheses 2, because we're using the one with charge of 2, oxide, with the change of IDE because it's a non-metal, making us change the ending. Now we're gonna talk about ternary ionic compounds, and this has of two types. And this ternary ionic compounds has three or more elements, and these are the types that you can be using: metal, which is a positive, and a polyatomic ion, which is a negative ion, polyatomic ion, which can also be a positive ion, and a nonmetal, which is negative. It can also be used as polyatomic ion positive and a polyatomic ion that's negative. So two types, one positive, one negative. And you'll be asking like what's polyatomic ions, and it's the one in the table um, like on the top. And as you can see, they usually have a lot of hydrogen and oxygen, and there's positive and negatives. And you can see like most of them are negative. And Tangerine type 1, it has 3 or more atoms, and the formula unit is positive ion first, negative second. Subscripts are used to show lowest ratio of atoms needed to have a compound of neutral charge. Parentheses are used when more than one atomic ion is used. So when we use atomic ion plus atomic ion, which is positive and negative, we will use parentheses. And the rule is positive first, and the name doesn't change. So when it's positive, it doesn't change, and it also when like the atom goes first, and then negative ion goes second, and the ending changes to IDE only for nonmetals. So it like the negative would be a pi-atomic ion, the changing wouldn't change. Only if there are nonmetals, it will change. Here's an example of one. Na, which is sodium, which has a charge of positive 1, and CO3, which has a charge of negative 2. So to balance it out, it would be Na2CO3 because we need 2 of sodium, so we can equal it out, making it sodium carbonate. And because it's not a nonmetal, the ending wouldn't change. But if it was a nonmetal, it would have changed. Now we're going to talk about Tangerine type 2. And the formula unit is same as Tangerine type 1. And the rule is metal first, then the charge in the non-metal, in the metal in numerals in parentheses, like the last time. Because some have like several charges, we will use a parentheses to like tell us which one we were going to use. And the negative ion first, and the ending change only if a nonmetal, as the Tangerine type 1, because if it's a polyatomic ion, the changing wouldn't change. Here's an example of magnesium charge 2. Because magnesium has two types of charges, we're only going to use the one that has two charges. So that's why we have parentheses type 2 in Roman numerals. And oxygen has a charge of negative 2. And this two balance out equally because it's positive 2 and negative 2. So we don't need to be sharing or transferring. And this would be magnesium, parentheses 2, because we're using the one with the charge of positive 2, oxide. And because oxygen is not a polyatomic metal, it is a nonmetal, we do have to change the ending to IDE. Now let's talk about acids. Acids are molecules with more or one or more hydrogen ion in the atom. Acids dissolve in water, and the formula AQ stands for aqueous, shown in dissolved in water. They usually taste sour, like a lemon. Ionic acid compounds, there's two types, binary and oxide. The binary ion does not contain oxygen, and oxyacids, as said in the name, it does contain. The formula unit is same as binary 1 and tangerine 1. Place IQ symbol at the end. Binary acids are, you have to prefix hydro because we're going to use hydrogen, ic at the end of the name, and attach the name of the ion. So we're going to see in the example below. And then the end, we place the word acid because it's an acid. For here, an example, hydrogen, which has a charge of positive 1, and chlorine, which has a charge of negative 1, is hydro because of hydrogen. Chloric, so chlorine, and we just put chlorine and then put the ec. And because it's an acid, we gotta put the acid. Then oxyacids. Acid is formed the atom name, so you have to, sorry about the spelling, to prefix ic or ade, sorry. Ions that end with are changed to ic or ic. Ions that end with ate are changed to ous. And here we have S H2SO4AQ. So hydrogen has a charge of +1 and sulfate has a charge of -2. And because we have to have two hydrogens so it can balance out, it's H2SO4 and its names are sulfuric because it has an ending of ATE. Oh, here at the ending I spell it wrong. Instead of R is ATE, sorry. And so ATE changes to ic or ric. In this case is ric, and acids will always go at the end. Now let's talk about covalent compounds. And the covalent compounds are formed when they share electrons between atoms. Type of bonds are usually between two nonmetals. So dynamic two identical atoms exist on a dynamic molecules that are in neutral state. Magic 7, the 7 nonmetals are usually paired together. This also includes hydrogen, which is not located in the magic 7s in the periodic table. There are gases. Their name is the name of the element plus the word gas, because they're gases. And the rules are: name element located in a similar group on a periodic table. Prefixes are both 1 and 2 elements when the subscript. Last name is with ID, so we have to change it. So here is the magic 7. They're the ones that are in yellow, and they're N, O, F, C, L, C, I, sorry, B, R, I, and H. And H, you can see it's not located in the 7 that are like located forming a 7. So here are the prefixes. Mono 1, D 2, 3, 3, tetra 4, penta 5, hexa 6, hepta 7, oxa 8, nona 9, and deca 10. So here's an example of hydrogen monoxide. Hydrogen is N, oxide is O. Because it says mono, which equals 1, we only will need one type of oxygen. So it would be monoxide, and we have to change the ending to IDE. So it would be monoxide in the oxygen. So nitrogen monoxide, which the formula would be NO. So that's all I got for you today. Hope you really learned how to change and write the formula unit and the rules. And hope this really helps.